Let's take a look at GPFS goodies. GPFS goodies is software that has been created to take a couple of complicated tasks that can dramatically increase the length of time that it takes to deploy NSD servers in a GPFS environment, and to simplify it down to just running a couple of commands. These are tasks that would normally take days to complete with a large system and are fraught with the opportunity for human error. There are multiple complex steps, and GPFS goodies allows you to accomplish those steps in a consistent and reproducible way, taking deployment times of such systems down from, again, a day or more down to just a matter of minutes, and also providing a repeatable process that follows current best practices. So let's take a look. Now that we have the GPFS goodies RPM installed on this management server, we can ask GPFS goodies to tell us what are the components within the software, within the package. Let's just take a look at two of these today. Maybe we'll touch on three. The first one is multipath.conf creator. This allows you to create a configuration, a multipath configuration file that is appropriate for use across all of the NSD servers in an environment. Even if you have multiple GPFS building blocks, this will create a single configuration file and optionally deploy it across all of them. So if we take a look at the help output, it gives us the options that you can use, but let's actually just put it into action. We're going to use the auto detect option, and it'll go out and discover the disk subsystems that are in use, and then create a resultant multipath configuration file. We can see that it allows use of friendly names right here, and that it includes appropriate definitions for different hardware classes, such as the 1813, which I believe is the DCS 3700, the 1818 is the 3700, and then 1746, which is the DS 3500 series, and so on. If we jump a little further down, we can get to the section where it's actually showing us the multipaths that it has defined. And it has gathered the worldwide ID information from the LUNs on the controllers by talking to the controllers directly using the SM client tools, the storage manager client tools, and creates a well-documented configuration file with best practice naming conventions, and this configuration file in a multi-building block environment has information about all of the building blocks, yet it can be deployed even to the building blocks that don't have access to all of the LUNs. Those building blocks will only use the entries that match the LUNs that they have access to. In addition to being able to create that file, it also has the option of letting you auto-deploy it. So we can say deploy, and it will copy the configuration file out, set up a modprobe configuration file that loads the SCSI DH driver, which prevents the system from spewing extraneous messages that are very noisy at boot time, can reduce the boot time, and it'll also update the NSD devices file to tell GPFS to actually use the friendly device names that have been created. let's do that now. X36N09, X36N10, X36N11, and X36N12. Those are our servers. Let me hit go. Now while it's doing this, I'll tell you that one of the distinct advantages of this model with GPFS is that when you're creating a file system with GPFS, because GPFS has the concept of globally accessible devices, the NSDs, when it is initializing block devices for use with the file system, we have to give it a name that the operating system uses to refer to that device. If we do not use friendly names and we do not have a NSD devices file specified to refer to them, then GPFS will be expecting us to pass names like devdm0, devdm1, and so on, which are the default names that the operating system uses when it creates multipath devices or device files. Unfortunately, there's no guarantee that dm0, for example, which may refer to LUN1 on a RAID controller on a disk subsystem, there's no guarantee that dm0 will refer to the same device on NSD1, server NSD1, and server NSD2. So this becomes very confusing and can even lead to data corruption if you end up referencing a device that is inappropriate by accident. The use of GPFS goodies eliminates that situation. So it looks like we're about to finish up the fourth and final node, and now let's go out to those nodes and take a look. So if we look now, we can see that the multipath.conf file that we've just created has been put into place. And if we ask the multipath system, what does it have to show us? We can see that it's using the friendly informative names. So it's coming off of storage controller DCS3860. That, in addition to being the model type in this case, it's also what the storage administrator has named that device. So its name is DCS3860. It's coming off of, or the preferred controller for this LUN is A, and the name of the LUN is LUN12. That is the name of it from a multipath configuration now. So now when we create our GPFS configuration file, or our desk file to specify which devices should be initialized for use, we can use this name, which is guaranteed to be consistent across NSD servers, rather than the devdm files. It makes it really easy for us to track down which device is involved in any troubleshooting activity that we might need to pursue.